Hello Internet, welcome to another video in Computer and Data Network series. In today's video we'll talk about transport layer protocols. Transport layer protocols are divided into two categories, UDP and TCP. Their primary function is to provide host-to-host communication between the systems or the networks. That being said, this video focuses on the frame format of TCP and UDP, which are the two transport layer protocols, by the way, and their small introduction. I do not wish to talk a lot about the features and properties of UDP and TCP. Instead, I wish to talk about the well-known ports of UDP, the well-known ports of TCP, and their user datagram format. But the discussion needs to start from the fact that UDP is a connectionless and unreliable transport layer protocol. It does not add anything to the services of IP except to provide a process-to-process communication instead of host-to-host communication. So that is the key point that you might want to note down. There are well-known ports for UDP that I wish to mention here in this video for the sake of knowledge to be attempted in multiple choice questions or so on and so forth. So I'll talk about the protocol and its port number, and I'll verbally talk about the description of the protocol, and you might just want to note this down because it's pretty important. Port number 7 is a UDP based protocol known as echo, and it echoes a received datagram back to the sender. Port number 9 is discard. It discards any datagram that is received. Port number 11 is users. It shows a list of active users. Port number 13 is daytime. Port number 17 is quote. Port number 19 is charge, and it returns a string of characters. And 53 port number is name server. It tells the information about the DNS. 67 is boot PS. Server port to download bootstrap information. 68 is boot PC. Client port to download bootstrap information. 69 is pretty famous, TFTP, trivial file transfer protocol. Then we have 111 RPC, which is remote procedure call. Then we have 123 NTP, which is simple network management protocol, and finally 162 is SNMP, which is simple network management protocol. These are the few famous well-known ports for UDP. All these protocols will not bother about connection orientation and reliability. Now talking about the user datagram format, the frame format for UDP, we know that any datagram will have some data that needs to be sent. So this is what we need to send, but we need to attach some additional information to that data for communication purposes. So that portion is known as header, the additional data, and the header of UDP is 8 byte long because source port number is attached, which is 16 bits. Then destination port number is attached, which is also 16 bit. And then we have checksum, which is 16 bits, and total length refers to the length of the data that we are sending. So if we are sending 100 bytes of data, I'll write down 100 here, but that 100 is expressed as one number that'll tell us about the length of what I'm sending. So all in all, it sums up to 8 bytes of data. So 2 plus 2 plus 2 plus 2 is 8 bytes of data, 16 bits each in each block. So that is how simple the frame format for UDP is. And the second type of transport layer protocol, well-known transport layer protocol, is transmission control protocol, which is known as TCP. It's a connection oriented reliable and it adds connection oriented and reliability features to the services of IP. And talking about the well-known ports of TCP, I'll again write the port number and the protocol. I'll verbally say the description. I will start with port number 20, which is FTP, File Transfer Protocol. 23 is Telnet, Terminal Network Simple Mail. Telnet is Terminal Network Simple. Telnet is used to monitor remote computers, so access through 23. And then we have 25 SMTP, Simple Mail Transfer Protocol. 53 is DNS, Domain Name Server. 67 is BootP, which is Bootstrap Protocol. 80 is HTTP, Hypertext Transfer Protocol. And 443 is HTTPS. And you could find numerous port numbers and protocols based upon TCP as well as UDP on the internet, but these were the few that I wanted to mention. And talking about TCP segment format, again, transport layer will attach some header to the data that I want to send. And this header could be 20 to 60 byte long. Just look at the difference between UDP and TCP. This is humongous. 20 to 60 bytes of additional data being sent with the data that we want to send is pretty large. So I'll talk about what additional things are being sent in this, because this header portion is being represented by this block. This is a 20 to 60 byte header portion. It contains source port, which is a 16-bit data, then destination port, again 16-bit. It contains a sequence number, which is 32-bit. 32-bit means 4 bytes. And then acknowledgement number, 32 bits, 4 bytes. Then the window size 16. Urgent pointer again 16. Just look at how much options are being provided. Then we have options in padding 32. By the way, this whole length represents 32 bits, so anything which is divided is 16. Then we have checksum, which is 16, and finally we have some sync bits that I'll draw separately in a large block. So this small little block is magnified here. So this is H length 4-bit, resend 6 bits, URG, ACK, return, sync, and finish. So these are the few other control bits which are located here, and you could read about the functions of all these things from either a book or from other source, but they're pretty explanatory, but except for the fact that a lot of options which are used for connection orientation and maintaining reliability are provided in the header of the UDP TCP. So this was a difference between the two transport layer protocols. Use the Datagram protocol, transmission control protocol. They primarily control pretty much everything which is happening on the networks. And super important topic, and I hope you liked it and it helped. And if it did, then please consider subscribing to the channel and giving it a thumbs up. And I'll see you in the next video. Bye.